The first question 16104, it says that at a given instant at bottom A of the ladder has an acceleration 4 feet per second square and velocity VA 6 feet per second, and both are acting towards the left. Determine the acceleration at the top of the ladder B and the ladder's angular acceleration at this same instant. So we are given with the information that there is a point A which is touching the ground and there is a point B which is touching the wall over here, and the angle you can see over here is 30 degree, and the length of the ladder is 16 feet. And now we have to find the acceleration at top of the ladder B and the angular acceleration of the ladder over here. So we assume that the direction towards the right I is positive, upwards J is positive, and for K it's positive when it is counterclockwise. So we are given with this information, we have to find the angular acceleration and the acceleration at point B. So for that we have to use the equation in which acceleration at B is equal to acceleration at A plus alpha multiplied by R, where it is B respect to A minus omega square R B respect to A. So for using this formula we have to find out the acceleration A, which is already given, and then there's alpha which we're finding, and there's acceleration B which we have to find, and this we have to convert R into the components of I and J. So for that we have this triangle. So as you know that acceleration at B can only move in a vertical position, so it means that it has the direction of J only, and for A it's given that it moves towards left, so we say that it is minus 4I, and then alpha we don't know, so we just write alpha and its direction is K, and we multiply it by 8 underscore 3I plus 8J. It comes from here. So this is the triangle with angle 30 degree and the hypotenuse of 16 feet, so we can get the vertical and the horizontal component by using the trigonometric ratios which you can see over here. 16 sine 30 is 8 and 16 cos 30 is 8 underscore 3, and then it's omega square, and we put the R B respect to A over here. So in this equation we can see there are three unknowns: omega, alpha, and acceleration at B. We have to find acceleration at B and alpha, but we also don't know what is omega. So for omega we know the formula, which is velocity is equal to omega R. So we know the velocity at A, which is 6, and we also know that the vertical distance is 8. So we divide 6 divided by 8 and we get 0.75. So omega we are using over here, we have to keep in mind that the movement is vertically, so we have to take the vertical component over here, because the omega has K and V is I in the I direction, and R should be in J direction, so that's why we took the vertical distance. And now we simply put the equation over here, all the omega value over here, and we solve for it, and we get an equation in form of I and j components. So we just compare the I and j components. As there is no I over here, so we put a 0, and then we can see that we are able to find alpha, which is minus 1.47 radian per second square. So as we assume that the counterclockwise is positive, so the negative over here shows that the direction was in clockwise direction. And when we're comparing the j component, we can put the alpha value over here, and then we are able to find that the a acceleration at b is minus 24.9 feet per second square. And as we can see that it's also in negative, and we assume that the upward direction is positive, so this negative indicates that the direction of the acceleration is downwards.